We're continuing with the trig identities, and we started looking at sine and cosine. Now we're going to and how to find them on the unit circle. Now we're going to use the unit circle and to try to help us find all the remaining. So the 6 key trig functions. We're also going to look at tangent, secant, cosecant, and cotangent. So how could we find these from the unit circle? So we need to remember, now this is in terms of the unit circle. If I can get my pen to work here. Sorry, there we go. Okay, so remember that tangent is sine over cosine, but in the unit circle, sine is y and cosine is x, so that's what they're saying here. So we know that secant is 1 over cosine, so that's the same as 1 over x. So I'll just show you the one more here. Obviously, cosecant is 1 over sine. And so that's, since sine is y in the unit circle, we have 1 over y. So same for cotangent, it just flips tangent upside down. So with this knowledge, we can find all of the 6 key trig functions just from the unit circle. So let's take a look at that. Okay, so we have a point on the unit circle. And remember what we said here. We know that the first point is the cosine or the x. The second point is the sine or the y. So I have a value of cosine. Let's see what they've given us here. So I have a value of cosine, negative square root of 3 over 2. Sine is 1/2. And from this basic knowledge, I can get the remaining 6 trig functions. So let's take a look. So, yeah, I think it's easier just, I know what they're doing with the x and y, but I think it's easier just think of it. Okay, well, that's sine over cosine. Tangent is sine over cosine. Well, if this is sine is 1/2, we put that on top. If cosine is negative radical 3 over 2, we put it on the bottom. Now remember with fractions, we keep, change, flip, so we just flip that upside down. We do some canceling here. We rationalize the denominator, and that's how we get here. So basically, tangent is just sine over cosine, and we know sine over and cosine, so we're good. Now secant is 1, yeah, again, I don't like the 1 over x. I don't think that's actually helping here. So secant is just 1 over cosine. So let's put 1 over the value of cosine. Let's flip that upside down because it's on the bottom. So it's like keep, change, flip. So 1 divided by a fraction turns it upside down. And then they rationalize the denominator again, and we get this. We can do the same for cosecant. It's 1 over sine, so we've done the same thing, 1 over sine. Flip it over, we get the 2. And lastly, cotangent. Cotangent is cosine over sine because it flips tangent upside down. So do the same thing, but just turn it the other way around. Simplify it, we get down to here. Okay, well, let's try another one. So we have, this is telling me cosine is square root of 2 over 2, and sine is negative square root of 2 over 2. Okay, so from this, I can find all the other trig functions. Let's do tangent. We'd have negative square root of 2 over 2 all over. I'm just putting sine over cosine. So if we keep, change, flip this, do you see that I have the same thing over top of the same thing? So, or you could think of it, these are just going to cancel. And I'm going to be left with negative 1. Now, I'm going to go to cotangent here because this is going to be easy. Well, if I had flipped this upside down, I'm still going to get negative 1. You see, if I'd made it square root of 2 over negative square root of 2, they would cancel. I would still get negative 1. Okay, so let's do cosecant is 1 over sine. So that's 1 over negative square root of 2 over 2. Being in the denominator here just flips that upside down. We rationalize this. We're going to get negative 2 square root of 2 over 2. So remember, that's multiplying the top and the bottom by the square root of 2. That's what I did here. Now you multiply across, you get this. The 2's can cancel. I've got negative square root of 2. And secant is going to be the same thing, except not with the negative. So see that now we're putting 1 over cosine. We're going to get the same thing, exact same process, except it's not going to be a negative, it's going to be positive square root of 2. All right, now they're asking us to start. They haven't given us the point on the unit circle, but they're telling us that the angle is going to be pi over 6. Now I haven't mentioned this, how this is easy, but what I'm doing, if I'm converting this, I'm multiplying it by 180. So this is my conversion, 180 over pi. So I could cancel the pi. But I know 6 goes into 180 3 times, 30 times. So 6 and 18, 3. So I get 30. So I've just, over the years, you notice if you get pi over 6, that's going to be 30 degrees because 6 into 180. So what's my point to this? Well, if I have a unit circle, remember how this goes? It's cosine, sine, and now it's the square root of 3 over 2 comes first, and in the sine, it's the square root of 1 over 1, which is 1/2. So I didn't need my unit circle, I just know from that little trick that I have my cosine and my sine. Okay, so they've given us right here, and we're just going to go through the process just like we did before. We're going to use all of the definitions to help us find, use these two to find everything else. So tangent, sine over cosine, just put those values over each other and simplify. Secant 1 over cosine, we just flipped it up, simplified. Again, same thing, flipping upside down. Lastly, cotangent, that's cosine over sine. So we're keep, change, flip, so just in case. So radical 3 over 2 times 2 over 1, those would cancel. You get radical 3. Okay, so let's do it again. Now, because it's pi over 3, I know 3 would go into 180. This is a 60 degree. So let's go back over here to our unit circle. It's cosine, sine. So it goes, so it's 30, 45, 60 every time. That's just going in order. So it's square root of 3, square root of 2, square root of 1, so that's 1/2. So sine starts as 1/2, so square root of 1, square root of 2, square root of 3. So square root of 3 over 2. And remember, it's always over 2. So here are my two values of cosine and sine. From there I can find everything else. Tangent is sine over cosine. So that's radical 3 over 2 divided by 1/2. I'm going to keep, change, flip this. I'll show you this one. Tangent's radical 3. Okay, let's do secant. So secant is 1 over cosine. So if cosine was 1/2, I've got 1 over 1/2. It'll flip upside down and become 2. Cosecant is 1 over sine. So that's 1 over radical 3 over 2. So flip that upside down. I'm going to get 2 over radical 3. I'm going to rationalize the denominator. I get 2 radical 3 over 3. Lastly, we have cotangent. Cotangent just turns tangent upside down. So I could have done this whole process, but I'm going to jump to the end here, and I'm going to just put tangent upside down, make that 1 over the square root of 3. Now that needs to be rationalized. Radical 3 over 3. Okay, so this chart is going to show you all of them here, but so I wouldn't memorize all of these things. The only thing that we could see here is that there are times that we're going to get undefined, but we'll talk more about those when we talk about the graphs of the functions. But just undefined is you can't have 0 in the denominator. So that can happen, and of course that just means that these are undefined at those points. All right, now one more. This is important. This is going through and telling us what the values of the 6 trig functions are in each of the quadrants. Now they're marking which are positive. You don't need to memorize this. All of the trig functions are built on sine and cosine. So obviously in the first quadrant, sine and cosine are both positive. So since they're all built off sine or cosine, everything's going to be positive. Now in the second quadrant, only sine is positive. So this is going through mentioning just the positive ones. So sine is positive and cosine is negative. Well, if you go through there, you can just build what would happen. Anything based solely on the sine function is going to be positive. Well, that's only cosecant. And anything built on sine and cosine, that'd be one positive and cosine would be a negative. Anything built on both of them is going to have one positive and one negative and become negative. So tangents build on both of them, cotangents build on both of them, And then lastly, secant is based on cosine. So if cosine's negative, secant must be. Following the logic here, let me just show you this one more. So tangent in the third quadrant is positive. Well, how would that be? Well, the sine is negative because it's y's. Cosine is also negative. Well, if tangent is sine over cosine, the two negatives would cancel each other out. If cotangent is built on sine and cosine, the two negatives cancel each other out. Now, all the rest of them are built on just one function, either sine or cosine, so one negative will make the rest of them negative. You can follow that same logic to see why only cosine and secant are positive in the fourth quadrant. Okay, now we're going to find all those trig functions using reference angles. So I think we saw some of this. I took a break in between filming some of these, but I think we've seen some of this. So if I'm looking at negative 5 pi over 6, remember that means I'm going in the clockwise direction. I'm going the wrong way around. And so if I put the unit circle in terms of a denominator of 6, halfway around would be 6 pi over 6. So I've come all this way, so I must be over here in the third quadrant. If I'm going the wrong way, I don't quite get to half, I get right here. My reference angle then would be the difference between negative 5 pi over 6 and 6 pi over 6. Do you see? My reference angle is pi over 6. So remember, reference angle is the distance from where we are back to the closest x-axis. So pi over 6. Okay, so we have pi over 6. Remember, 6 goes into 180 3 times, so this is 30. This is a 30-degree angle. So the sine of 30, the cosine of 30. So I'm going to just go for this here, but so this is the first angle. This is radical 3 over 2. This is 1/2. Okay, now the only thing I have to keep in mind is the value of these. This isn't really 30 and 30. We're actually we're using that information, but we're in quadrant 3. So in quadrant 3, y's are negative and cosines are negative as well. Okay, now we did a problem just like this before. The only thing that we're now going to extend is we're going to put the definitions of the other 4 trig functions based on this knowledge, and we can solve it. So okay, so tangent, they didn't show it here, but so tangent would just be putting sine over cosine. So tangent would be negative 1/2 over negative square root of 3 over 2. You're going to flip that upside down. So I didn't show the negative. Well, I should, but okay, so I flipped it upside down. So the 2's and the negatives are going to cancel. I'm going to get 1 over the square root of 3. When you rationalize that, I hope you see that'll turn into radical 3 over 3. So cotangent is going to turn this upside down. So now I'm going to go back a step. You'll get to the same place, but I'm going to turn this one upside down. It's the same thing. I'm going to get radical 3 over 1, or just radical 3. Secant is going to turn cosine upside down. So that's going to be 1 over negative radical 3 over 2. So I flip this, get negative 2/3. Sorry, cosecant is going to turn sine upside down. It's going to be 1 over negative 1/2. So that's negative 2. Okay, and there's the process. So the key was just this. Where's our reference angle? What is our reference angle? What quadrant is it in? And then find sine and cosine, and we can find all the rest. So let's do this one more time here. So negative 7 pi over 4, I'm going the wrong way around the unit circle. But so if I was, so I'm going clockwise. But so if you were trying to think in terms of this is pi, we could think of this as 2 pi. Do you see how this could be thought of as 8 pi over 4? So we're going all the way around here. We're somewhere over here. We went the wrong way around, but we're going to be in quadrant 1. So we go all the way around. We're not quite to 8 pi over 4, but we're past that point. So I'm right here in this quadrant. So my reference angle is the difference between negative 7 pi over 4 and 8 pi over 4. Do you see that this distance is going to be pi over 4? So I'm looking for the cosine of pi over 4, the sine of pi over 4, and I know that I'm in quadrant 1. Well, That's an easy one if you remember the table. Just you could think it through like the square root of 3, square root of 2, square root of 1, but this one's pretty easy. Okay, so we have the two basic ones. So let's find tangent, sine over cosine. It's going to be the same thing over the same thing. Do you see that? So it's going to be 1. Cotangent's going to turn that upside down. Well, 1 upside down is still 1. Cosecant is going to turn sine upside down. So I'm going to have 2 over the square root of 2. So I did that a little quick, but let me show you. So this is what I should have done. I'm jumping ahead, and I shouldn't do that. This is 1 over the square root of 2. Now that will turn it upside down. I get to here. I rationalize the denominator, and I get 2 square root of 2 over 2. I can cancel that down, square root of 2. So just some basic college algebra kind of stuff. Okay, secant is going to be 1 over cosine, so I'm going to put that upside down, but you see all the numbers are the same. So I'm going to wind up with radical 2. So I think we're done here. Let me check. Yeah, we are. So here's the key. What I want to do is I want to find the two main functions, sine and cosine, using the reference angle and what quadrant they're in. The quadrant is super important so that I make sure that I'm marking the correct signs. Once I have that bit of information, I just use the definitions to solve everything else.